Now, here we go. Check this out. Check this out. How big did we say a white dwarf is? We said it's about Earth-sized, okay? It should be about Earth-sized. But not every white dwarf is the exact same size, because depending on how the star dies, you could have different masses, okay? So white dwarfs can have different masses, so they can have different sizes. Now let's take a guess. Let's say we had 2 white dwarfs. Let's just call it, I'm just going to write an A and a B. And let's say that A had a really high mass and B had a really low mass. Which one does it seem like would have a bigger size? Just if I didn't even tell you what we were talking about, which one does it seem like would have a bigger size, like physical space that it takes up? Seems like A. But based on what I'm saying right now, you can kind of guess where I might be going with this. Let me show you a little quick diagram from the book. Here's Earth. Here is a white dwarf with the same mass as our sun. M sun right here stands for mass of the sun. So 1 mass of the sun. This would be a white dwarf with the same mass as our sun. And this is a white dwarf with 1.3 times the mass of our sun. And which one's bigger? It's the one with more mass. And if we got an even bigger mass, it would be an even smaller size. So yeah, something's up with the density here. So it turns out that unlike every stage that you learned about in the last few videos, where bigger masses meant bigger stars, for white dwarfs, it's backwards. Bigger masses means smaller stars. Now, why is that? Well, okay, check it out. If you get more mass, what do you also get more of? Mass creates what? If this one over here, oh wait, I lost myself. If this one has more mass, what does it also have more of? Gravity. Remember, what was fighting the electrons? What was fighting those degenerate electrons? It was the gravity, right? So this grid of electrons was determined by the strength of the gravity. And remember, they fight each other because they hate each other. It's the strength of their hate, right? And hate can only go so far. You can almost imagine that they were fighting each other with little invisible springs. And if you squeeze tighter, what would happen to the size of this grid? If you squeeze tighter, what would happen to the size of the grid? Remember, imagine it's like little springs between them. It would get smaller. That's correct. It would shrink. So even though adding more mass or having more mass means that that white dwarf would have more electrons in the grid, because the gravity is higher, it can squeeze these guys together. So they're like holding each other apart, like, no! No! But as gravity gets stronger, there's only so much strength in those electrons. They're like, no! No! And that ends up compressing the whole white dwarf. So, yeah. That's true. Yeah. And as they get crushed together tighter, they hate each other more, and then gravity just keeps on crushing them. Try not to hate, guys. Now. Okay. So, larger masses mean smaller sizes for white dwarfs. But, okay, there is a limit to this, okay? There is a limit to this. Check this out. Check this out. If we keep adding more mass, or if we keep looking at white dwarfs with more and more mass, this thing keeps on shrinking. There's a limit to how much you can shrink, right? So it turns out that if you look at all white dwarfs, there is a maximum mass that white dwarfs can have, okay? There's a maximum mass that white dwarfs can have. And we have never found any white dwarfs above that maximum mass. Because they keep shrinking, the more mass they are, there's a certain, if you crush it too much, it's just zero size, right? So what is that maximum mass? Okay, let's talk about that real quick. Where is my document? There we go. The maximum mass that a white dwarf can have is 1.4 the mass of the sun. 1.4 times the mass of the sun. That is the maximum mass that any white dwarf can have. So, not that much more massive than our sun is right now, okay? And we know that that amount so exactly that it has a name. This right here is called the Chandrasekhar limit. It's called the Chandrasekhar limit. And I will write that down because it's named after a guy with a name that's pretty long, okay? So this limit, the maximum mass that white dwarfs can have, is called the Chandrasekhar limit. It's the limit on the mass of a white dwarf. But white dwarfs usually don't have to worry about that limit, because once a white dwarf is made, it's locked into one mass. So when our sun turns into a white dwarf, it will just be a certain mass, and nothing is adding mass to it, and nothing will be taking mass away from it. So it won't have to worry that there's a limit, but there is a limit. We don't see any of them more massive than this, okay? By the way, let me go back to this picture. Our sun has a mass right now of 1 solar mass, okay? Our sun has a mass of 1 solar mass, okay? Now, okay, when our sun dies, would we expect our white dwarf to be bigger than the Earth or smaller than the Earth? Let's see if we can figure that out. Would we expect our, or the same size as the Earth? Okay, we're getting basically guesses all over the place, which is what I usually get. Let's put it all together. Let's see if we can walk our way up to it, okay? I'm not going to say what the right answer is yet, okay? Now, right now, the sun is super huge, right? Sun's super huge. It has 1 solar mass, though. Now, when the sun dies and has its planetary nebula, what's going to happen to most of that mass? What's going to happen to most of the mass of the sun when it dies? We actually were mentioning this towards the beginning of this video. It's going to fly away. So that means that our sun, like all other stars that become white dwarfs, we are going to produce a white dwarf with less mass than the original star, okay? Now, that means that our sun is going to produce a white dwarf with a mass less than 1 solar mass. It'll be point something. Like 0.4 or 0.3, I don't know, right? So if our sun is going to make a white dwarf with less mass than this one, will it be bigger or smaller in size than this one? Bigger. So because our sun is going to produce a relatively low mass white dwarf, and we said that higher masses make you smaller for white dwarfs, then this is just the reverse. You guys are right. When we put it all together, it makes sense, right? Our white dwarf will be bigger than the Earth because it's a lower mass one. Okay, now, a little bit more I need to say about white dwarfs, and then we'll move on to other things.